The thing is, when you try to, okay, when you try to, when we say that there must be a antinode at the open end, that means a particle will displace with maximum amplitude and then it will come back. Is that right? So there, what is happening is that we expect a antinode to form, expect a antinode to form exactly at the tip of the, exactly at the tip of the air column. But the thing is that if you try to study this in terms of pressure, we know that wherever there is a displacement antinode, there must be a pressure node. Is that correct?
Yes, sir.
Yes, sir.
So the thing is, this pressure must be equal to atmospheric pressure. If it is a pressure node, pressure in the air column must become equal to atmospheric pressure. The thing is, because the particles are moving over here, the pressure doesn't is not equal to atmospheric pressure at the end itself. It will become equal to atmospheric pressure after little extra distance. Did you get the point? Because still the molecules are fluctuating here continuously. The pressure at the open end cannot be equal to atmospheric pressure. So the pressure node forms not at the exact end of the tube, but it will form slightly outside. So this additional distance after which the pressure node forms is called end correction. Did you get the logic?
Yes, sir.
Yes, sir.
So if you take a air column at open organ pipe or open at both ends, we know that there will be end correction to the right as well as to the left.
Yes, sir.
And here we found the general formula for this open organ pipe is how much? NV by 2L. We found it as NV by 2L, where L was the length of the organ pipe. When we try to express the wavelengths in terms, when we
Yes.
try to correlate with the length, wavelength and the length. But the thing is, here length is not L, the effective length is L plus E plus E. So
Yes, L
that's
plus
why
2.
after end correction, we write it as L plus 2E. And the thing is that this end correction, when they tried to find it experimentally, they found that its value was 0.6 times the radius of the tube. It was 0.6 times the radius here. In the radius is mentioned. Is it okay? If this is the radius of the pipe, 0.6 times r is the radius. So after end correction, the frequency of nth harmonic will be Nv by 2 into L plus 1.2 r. Whereas if at all if we consider a closed organ pipe, closed at one end, so here there will be only one end correction.
There are also one times we have to do end correction.
Yes, so this will be 2n minus 1v by 4l plus e, right? So here you have to do the end correction once. Did you get the point?
Yeah.
Now, uh, I'll give you time to copy this. Now look at this resonance tube experiment. Have you ever performed in lab?
Not
Mm,
in lab, sir, but theoretically we have learned.
Okay.
yeah.
The thing is, whenever there's a phenomenon called resonance, whenever frequency, external frequency matches with the internal frequency of the system. Okay, so the vibrations
Then
are
it starts vibrating with
Large
larger.
in
larger amplitude.
large amplitude.
So as per that logic, here if I take a frequency tuning fork of frequency f, and let's say if at all this matches with this, when will this match with the air column? If it is in any one of its natural vibrational frequencies, is that right? So let's say
Yes, sir.
it is oscillating in first harmonic. Okay, so here it must be node antinode over here, node antinode. So we know that this distance is lambda by 4. The length is L1. So we call this as first resonating length. So what we usually do is that we put a tuning fork, hit it, then we slowly lower down the level of the water inside this tube.
Till
So
yes.
till we hear maximum sound. So that that's the event where we get the first resonance.
Yes,
We
sir.
call it as first resonating length. Okay, we say L1 is must be equal to lambda by 4. Then we again continue to move, decrease the water level. So second resonance, we know that it must occur at lambda by 3 lambda by 4. because this is a
Yes.
closed organ pipe. So this
There is
whatever
a 1 by 3 times of the original length, no sir, according to resonance thing that we learned in 10th.
according to
It will be
resonance,
three times the original.
It
three
will
times
3 times, 1 by 3 times the original length, I mean first resonating length.
three times the first resonating length. You see, this is
Yes.
lambda by 4. This must be 3 lambda by 4. You can clearly see, right? Antinode to
Yeah.
node, node to antinode, antinode to node. So this will be 3 times the original length. So that will be 3 lambda by 4. Okay. So L2, we got as 3 lambda by 4. So L2 minus L1 must be how much? Lambda by 2. So lambda is equal to 2 twice that of L2 minus L1. So from this, if you want to find the velocity of sound, we know that that is V is equal to lambda times F. So from this, F into lambda. So from that, we can calculate the speed of sound at that given temperature. And we haven't done this, but we know, okay, that the relation between speed of sound at 0 degree Celsius and T degree Celsius is this. So using that relation, if you are interested, we can find the velocity of sound at 0 degree Celsius. Did you get the experiment? So this is a resonance tube experiment. Now, if you want to make it slightly complicated, what we can do is that we know that the pressure node or the displacement antinode doesn't form at the tip, but it will have some end correction. So what should I properly say? I should say that lambda by 4 will be equal to L1 plus E. Is that correct? Are you people following?
Yes, sir.
You see, Nachiket, the thing is there must be end correction, right? If you want to
Yes.
get the accurate result, end correction. So that means the nodes, the waves antinode must form here and node must form here. So this length
Yes.
must be lambda by 4. So when you consider end correction, lambda by 4 must be equal to L1 plus E,
Yes.
whereas 3 lambda by 4 must be equal to L2 plus E.
Yes.
So when you subtract these two, L2 minus L1 will still be lambda by 2. So is there any change in expression of sound?
No.
So that's why we usually ignore end correction while doing the experiment. Did you get the
Okay.
point? But if you want
Yes.
to find the value of end correction, what we can do is that we have these two equations, right? Divide equation
Yes.
2 by equation 1. What you'll get, L2 plus E is equal to 3 lambda by 4. L1 plus E is lambda by 4. You get this as 3. So we know the length, second resonating length and first resonating length. From that, can we calculate the value of E?
Yes, sir.
So that's how you calculate the end correction in resonance tube experiment.
Yeah, got it, sir.
So others, you might be facing difficulty in understanding it. Kindly wait for 5 minutes. The lesson is almost done. The chapter is
Yes, sir, I
almost done.
can. Yes, sir, I can.
Sir, in the end correction part, in Fn, NV by 2 into L plus 1.2 R, how did you get, sir?
How did I?
Get
You're asking this expression. You see, this is an open pipe, right? Here we solved
yes,
for open organ pipe. What's the relation? NV by 2L. That's what I
yes, sir.
used.
Yes, sir. And after that, you put in the denominator 2 into L plus 2E, right? And after that, you wrote 2 into L plus
I can
1.2R.
take both ends, no, Amok. So total length will be L plus 2E.
The thing over
No,
here
sir.
is this E. This is the relation. E is equal to 0.6 R. That's what they found experimentally
Okay, yes.
based on experimental calculations. So coming to the sonometer experiment, you can see the diagram. So what they usually do is that, you can imagine the diagram easily. They fix the wire at one end. At the other end, they hang some mass through a pulley. So definitely there will be some tension developed in the rope. Is that right?
Yes, sir.
Something like this. They fix a rope over here, then they hang a load through this, and then these two will behave like a fixed ends and then vibrate. So the vibration can be in any n number of loops. Is that okay? So it's like a stationary wave formed between two fixed ends. Is that okay? So what do you know the
Yes, sir.
expression? We know that frequency is equal to V by 2L, NV by 2L, right? Actually, this expression is
Yes, sir.
different. NV by 2L. Now, what do you know about the value of V? V is under root T by mu.
Okay, yes, sir.
So that's why you get this as T by mu. So frequency is NV by T by mu. That's what says the sonometer experiment. Understood the point?
Yes, sir.
So with this, the syllabus is done.
Okay.
Okay, sir.
So try reading the textbook. Any doubts? We'll discuss them on Monday. Okay. If you have any, you read the ISC textbook wherever you are having doubt. You mark it and explain in the class because we have 1 week right. So we'll prepare in
Yes.
that 1 week. I'll also help you. Now for others
Okay.
those who have joined late and not able to understand, kindly wait. So those who have understood it can leave.
Can you just move
Sir, could you just go
right?
right to the end, sir? That
Yes.
end correction part for
Yes, sir.
reference to you? Yeah, thank you, sir. Just like 2 minutes.
Thank you,
Okay.
sir.
Okay.
Thank you, sir.
Thank you, sir.
Now, others, should I share the recorded class or should I explain again?
Yes, sir, you can share the recorded class.
Okay then.
Like I know most of the things I have read from the textbook.
Okay, very good. Okay then, I'll share it in the group.
Yes, sir. Thank you, sir.
Thank you. Dheeraj, any
Thank you, sir.
doubts?
Nothing, sir. I'm just
Okay.
leaving. Thank you. I just
Okay.
was writing the last part. Thank you, sir.
Okay.